Again, I'm not going to suggest graphing this out is going to be helpful, but you could check them to do that. They want you to use a squeeze theorem, which means they want to find an upper and lower bound to this. And this is the worst part about the squeeze theorem, is finding that. So I need to find something, by the way, in some open interval containing 0. So I'm looking above that, and you know, my suspicion about this guy over here, this guy here, the most it could be is 1. And the least it could be is -1. Right, so I'm going to write that down. So the least it could be is -1. By the way, I'm just talking about that red highlighted. And the most it could be is 1. And then over here, I'm looking at the x, and so to the left and right of 0, I'm just going to put the absolute value down. The reason for that, I want to kind of visualize what that would look like to me. And what would that look like? I know I'm going to get an absolute value function that looks like this. That's this one. And I'll get something that looks like this over here. I clearly got a squeeze, and this is clearly in between those. Now, what I'd recommend you do over here is, you know, before saying that's true, is I would recommend you graph it out. Graph. And what are you graphing out? 3 functions. Y equals the absolute value of x. Y equals minus the absolute value. No, you don't need technology to do that. But what you want to do is you want to show that y equals x times cosine 5 over x is actually between this, all right? Bouncing around between that, all right? So here's the deal. Do that, and you'll see it. I'll post a video of that as well, right? What do we know? Well, let's take a look at that. The limit as x approaches 0 of the lower one, which is minus the absolute value of x, is 0. And that's really the same thing as the limit. Oops, sorry about that. Let me erase that. I know the limit of the upper limit, x goes to 0, of the absolute value of x, also 0. So what does this tell me? By the squeeze theorem, it tells me the limit as x approaches 0x cosine 5 over x is also going to be equal to 0. It's not defined as 0, though. So look at the work. I want to point out this is written down for you. I did that limit. And again, we're using a squeeze theorem. And we should state we're using a squeeze theorem, right? Actually, they stated we use a squeeze theorem. We're using a squeeze theorem. Thank you.